Hello and welcome to Project 152, your weekly specialist exam prep. If you stick with me until the end of term 3, we'll do every single question QCAA has ever done. Go down to the link in the description. You can download last week's questions. You can download next week's questions. Do those. If you don't know what I'm talking about, click the link. Go ahead. This week we're doing the week 4 solutions. So again, link in the description. We're going to do these questions. They're tech active questions, so make sure you've got your calculator ready. And here we go. So first question, an absolute classic. We've got two particles following these two vector function paths. When do they collide? So this is going to take a little while because we've got to find out when are our x coordinates equal, when are our y coordinates equal, and when are our z coordinates equal. So I'm going to write this one out. So that's our first one, t squared minus 4t, t squared minus 4t, minus t squared plus 2t, minus t squared plus 2t. And we need to find out when they're equal. We also need to do the same for this one. Done. 2t squared minus t plus 3, 2t squared minus t plus 3, and 3t plus t squared, 3t plus t squared, and our last one. Need to be just a tiny bit careful here. Negative 6 minus 5t. You can see here, our k component is negative 6 minus 5t. You can instead expand the brackets and make it negative 6 plus 5t, but that's fine. Equals t squared equals t squared. I'm not doing that all by hand. I'm doing it on my calculator. Here's my calculator. Let's go. We're going option, best friend here, calc, and we're going to do a calc, and we're going to do a solve in. All right, we're just going to type in our first one here. Instead of t's, we're just going to click x for x instead. Just easier on the calculator. All right, so I've typed it in. You always want to do one last check. X squared minus 4x, x squared minus 4x, negative x squared plus 2x, negative x squared plus 2x. Yep, let's execute it. More solutions may exist. Always good to remember that. T equals 0 or 3. So that's for this one right here. So that narrows down our options. Either A is correct or D is correct because that's when our two particles have the same x coordinate. All right, do the same. Solve this one. Double check. 2x squared minus x plus 3, 2x squared minus x plus 3, 3x plus x squared, 3x plus x squared, x's instead of t's, and we calculate it. Come on, do it. And it gives us 1 or 3. So I'll write that down. Okay, so it seems to me that the answer must be D because the x and y coordinates of our two particles are the same only at time 3. All right, let's double check by solving that. I've typed it in exactly as it is there. I've had to nest some brackets, but it seems to be okay. Let's test it. More solutions might exist. 2 and 3. Okay, great. Now there is only one time when the x coordinates, the y coordinates, and the z coordinates are all the same, and that time is t equals 3. I believe there's our answer. All right, celebrate. And next question. Okay, next question here, Leslie matrix, right? Now, I want to talk about this briefly. Start of 2018, start of 2025. And people say, well, do I raise it to 7? Do I raise it to 6? Do I raise it to 8? I like to dumb it down by just drawing the timeline so I don't make a mistake. All right, so this is the start of 2018. Let's go together. 2019, 2020, 21, 22, 23, 24, 25. All right, so there is 2025. How many jumps did I do to get to the start? Because it says very clearly the start of 2025, the start of 2018. 1, 2, 3, 4, 5, 6, 7. All right, there have been 7 jumps. Why did I do that? Because you could be really tricky with this question, and you could say at the start of 2018 and at the end of 2025. If you did that, you'd have to go one more bit. The end of 2025, the start of 2026, it's the same deal. That would be 8, not 7. Okay, if you said the end of 2018 and the start of 2025, that would be 6, not 7. So, play it safe, draw yourself up one of these. All right, so we want to know N7, so after 7 years. And that's going to be the Leslie matrix to some power, and we now know that we want power 7, not 6, not 8, and times by N0, the initial population. All right, so if you still sort of need a little bit of convincing there, N0 is right here. If we did L to the 1, just L times N0, we'd be here. 2, 3, 4, 5, 6, 7. Done. Calculator. All right, so I'm not going to do this every time I do a matrix on the calculator, but I am going to do it this time because we're right at the start of our little project here. There are 3 different Mat VCT buttons, and they do 3 different things. This button that appears when you first turn on your calculator, it's for entering like big matrices into. I very rarely use this button. I like using other buttons. All right, what else do we have here? We have this math button. Now, anything you find in the math button is all about entering things. Entering a derivative, entering a second derivative, entering a log. This is for entering matrices in. 2x2s, 3x3s, blah, 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 blah. There is one last place where you find MATVCT, and that is in the option menu. What is this for? Calculations. These are calculations of matrices and vectors, and you can see lots of calculations there. All right, so if you play with it a few times and you ask yourself, where do I find where to enter things? Where do I find where to calculate things? Where do I find where to calculate the big things? And you practice, you'll know where to find those, and you'll get really fast, and you won't be lost all the time. All right, so what am I trying to do? I'm trying to enter something, so I'm going to go into my math. I'm going to go into my MATVCT. Now, what am I trying to do? I'm trying to enter a 3x3 matrix. I'll put those numbers in. Now, as I've said before, you've got to double check it to the power of 7. And then we're going to multiply that by another matrix. And this time it's a 3x1. And I'll enter that stuff in there. Now, hopefully I've done that correctly. If I execute that, I get these things right here. And the question is the best estimate of the total female population. So if I add those numbers together, I get a number close to 4,000. It's about 4,200 maybe. So I think my answer should be B. All right, let's double check it. It is. Done. Nailed it. Celebration. Next question. All right, so here's our next question. Now, sometimes I think the QCAA is just feeling really kind because you don't really need to know anything about anything to be able to do this. You just need to know some like year 10 trigonometry. So let's see. Given the coordinates of point A, all right, there's point A, are 3, 4, 6. And our entire goal, once we know that coordinate, is to find that angle right there, that angle of elevation. So we're going to have to do this in 2 steps, I believe, because we know, and let's start putting stuff in. What do we know? We know this height. We know the height is 6. Okay, great. What we don't know is like the length from O to right here. We don't know that length. Let's call it X. Now, obviously, if I know X, and if I know 6, and I do know 6, then I can use basic trigonometry, because that's a right angle right there, to find that angle. So finding X is my like intermediary goal. Okay, what else do I know? Okay, I can draw a new triangle from there to there and from there up to there. Okay, there it is in pink. Now, it may not look like it, but this is a right angle, right? Because this is coming straight out of the page, and that's going straight across. They're at right, the X and Y axis are at right angles to each other. All right, how far out of the page are we? We're 3 units out of the page. We get that from our number 3 here, and we're 4 units across the page. Okay, it might be confusing in matters. X refers to the dotted line. Okay, you should immediately know what X is. And I'm talking about don't open a calculator, don't do any thinking at all. You should know straight away X is equal to 5. Why do you know that X is equal to 5? Because you've been around maths for a long time, and the numbers 3, 4, and 5 are a Pythagorean triple, a Pythagorean triad. You can do it, right? You can do 3 squared plus 4 squared. 9 is 9 plus 16. The square root of that is square root of 25, which is 5. But I just know. X is equal to 5. I hope you do. Okay, last step. Because I know X is 5 and because I know the height is 6, I can do some right angle trig on this thing. So I can say tan of our little thing here is equal to opposite adjacent is equal to 6 over 5. All right, inverse tan, 6 over 5. And our answer is supposed to be in radians. So let's get our calculator out. Make sure it's in radians mode. Type that in. We should get an answer. Okay, my apologies. It's over the top there, but it doesn't matter. Shift 10 bracket 6 over 5. And we should get an answer, 0.876. I see 0.88. That is close enough for me. Our answer is B. Okay, very straightforward. Even if you haven't done these ones in class before, you should just be able to nail it. Celebrate, and we're on to our short response questions. All right, so we are going to use a vector method to determine the area of the shaded face of the pyramid. All right, so vector method, triangle, we should be thinking cross product. Now, to be able to deal with a cross product, we need two vectors, right? Two vectors that are two sides of our triangle. So I can see the starting point B right here. And I'm going to draw a vector from B to A and a vector from B to C. Okay, so there are my two vectors, BA and BC. We want them starting from the same point and emanating outwards like that for this cross product thing to work. All right, so we need vector BA. Now, vector BA is going to be equal to vector OA, that's this one here, minus vector OB. And we can write that out, but it's going to be like 1 mark just for finding this vector. So we can just jump straight to whatever it is. And so I'm going to do that. 1 minus minus 1. So 1 minus minus 1, 1 plus 1 is 2. 2 minus 2 is 0. And 5 minus minus 2 is 7. Okay. Given we have a picture, we should stop and check that we believe that we are correct here, right? I look at this 2, I look at this 0, I look at this 7. All right, let's look at the 7 first. From that point to that point, have I gone up 7 units? And I feel like the answer is yes. That feels right to me. Okay, from this point to this point, does it look like we haven't moved left or right? Well, it doesn't really look like we haven't moved left or right, but it also says not to scale. Okay, so deceiving. But I'm looking at the 2, I'm looking at the 2. The answer could only be 0, so I'm feeling good about that. This number here has me panicked. It just doesn't feel right. So what's happened? Okay, it says B negative 1. And then, wait, okay. So now it's really not drawn to scale, right? Because a B of negative 1, that feels to me like it shouldn't be over here. It shouldn't be in this quadrant. This feels like positive x's. It should be like over there. So someone's done something strange with the orientation of this thing. If this is x equals negative 1 and like into the page is x equals 1, then I'm okay. It feels okay. But it does feel like they've drawn a misleading diagram here. Someone in the comments tell me what's going on, because this feels like a very strange diagram to me. Okay, BC. Okay, so to do BC, we're going 0 minus minus 1. So that's 1. We're going 5 minus 2, which is 3. And we're going 2 minus minus 2, 2 plus 2, which is 4. Okay, so from this point to this point, did we go up 4 units? Oh, I see. This negative 2 means it's lower down. It's actually like, it is back from the page. I just couldn't see in 3 dimensions. Whoa. Okay, well, if you can see that now, let me know, right? This point is not in this quadrant. It's over there, but down, and so it looks like it's in, but it's actually, whew, okay, that makes sense now. So negative 1 to 0, yeah, that makes sense that I would need to go forward 1 unit. From 2 to 5, yeah, that makes sense. I have to go forward 3 units. And from negative 2 to 2, that makes sense. I have to go forward 4 units. Why am I bothering with this like pedantic, like, oh, I'm going to double, triple check. I'm going to look at my picture. Well, I've got all these tools. I've got one exam that's worth 50%. I'm going to spend an extra 10 seconds double checking at each step, especially when they're kind enough to give me a picture. Even though it confused me in the beginning, it makes you think, hey, am I going down a wrong path? And once you've convinced yourself that you're not, you can start moving forward again. Okay, now that I've got two vectors, this question is pretty much over, right? Because the area of any triangle is equal to half of the magnitude of the cross product of two of the sides. And that's really it. That's all I'm trying to do, determine the area of the shaded face. So I have a calculator. I should definitely use it. Let's go. To be honest, it doesn't feel like I'm doing 4 marks worth of work, but hey, what do I know? BA times BC. All right, so I need to do a vector calculation. Where do I find vector calculations? I find them here. All right, so go a vector calculation? Yeah. Oh, there it is. Let's go back again. The cross product. So I'm just going to do the cross product first. That's going to be my starting point. And I need to do the cross product of two vectors. So now I need to enter those vectors. So remember how to enter our vectors. We go into our math portion. And this is where we get to do our entries. Now, vectors get entered across the page. So I'm going to be entering it as a 1 by 3. 2, 0, 7. And then I need a comma, which I'll find here. And then I enter another 1 by 3. 1, 3, 4. And then close the bracket on both of those. Press enter. And I get this vector here. That is the cross product, -21, -1, 6. Now, you know, what might I do if I was in an exam situation? I might, if I was in an exam situation, grab one of these calculators and find the magnitude of this, because that's my next step. I'm finding the magnitude. But if you're really good with this calculator, what you might do instead is something a bit more like options. I'm going to do matrices again. I'm going to do a norm. And so a norm just finds the magnitude. That's what our norm is. Now, the norm of this. Now, you might be tempted to just enter it in, and that's probably a good way to do it. But there is another way to do it as well. You can arrow across until it says vector, right? And then you can press Shift Answer. Now, what is that doing? That's saying find the magnitude of the vector that was the answer to my previous work, right? You can't just press answer, right? If you press norm answer, it's going to say that's not a vector. It doesn't recognize it. You've got to say it is a vector and it was the answer to the previous question. Execute that and we get root 478. So that is this piece here, the magnitude. Now, of course, that is not our answer, or I guess it is our answer now, complete, right? We could say half of the root of 478. It is a tech active question. They are asking for the area of the shaded face. Look, I really think that this is it, units squared, because I don't think they've told us anything about meters or centimeters or anything like that. We can also express this as a decimal. 21 point, oh, not 21, because I need to divide, I forgot to divide by 2 in my calculator. That's better. 10.93 units squared. Now, I am interested, like, it just feels like so little work. How was the QCAA giving me 4 marks for this? All right, so I have double checked it. They give us 1 mark for getting these correct. That's harsh marking, right? But also, it's easy to do, but it means that if you make a single mistake here, 206 or something, you're getting no mark, right? So you need to get both of those correct in one go. Now, incredibly, they give you a mark just for writing this, just for writing that the area is equal to half of the magnitude of those two vectors. So there's your mark. They give you a mark for calculating this, and they give you a mark for your answer. There is 4 marks. Let's celebrate, and one last question. All right, so another vector question here, and actually part A is just determine AB. Now, look at this. Determine AB, and you're only going to get 1 mark for it. So when it comes to questions where it says determine this, and you see 1 mark, it means just give me the answer. You don't have to do anything except give them the answer. You don't have to show a whole bunch of working. All right, so what is AB? Well, you know that it's OB minus OA. So you really just need to do it here like we did in the last question. 1 minus 3 is minus 2. 1 minus minus 1. 1 plus 1, 2. And 6 minus 3 is 3. Okay, so I'm doing that like this to show you that if it's 1 mark, you can just do it like that. Now, of course, the flip side is the less working you show, it's potentially more likely that you're going to get your answer wrong. What I'd probably be doing next is like double and triple checking this, right? Like I'd be going, oh, really? Am I correct? Well, from A to B, from 3 to 1, is it really negative 2? Yes, it is. From negative 1 to 1, is it really 2? Yeah, it is. From 3 to 6, is it really 3 units? Yes. So I'm sort of working in reverse there. Rather than doing B minus A, I'm doing A to B and double checking that my answer is correct. Okay, determine the Cartesian equation of the line that passes through point A and B. Okay, so there's a couple of different ways to do this, but the way that I like to do it is just determine the vector equation of the line and then determine the Cartesian equation of the line. I know that some people work with like, hey, this is the Cartesian equation of the line and here's how you find these points. I just do the vector equation and then convert it to a Cartesian. It's a nice little skill to have, and you can always do it. Okay, so what is the vector equation of a line? Come on up. There it is. Vector equation of a line, R equals A plus KD. So let's write that up. R equals A plus KD. All right, vector, vector, vector. All right, so what is A? A is the starting point of our line. Now, we can choose either of these to be the starting point of our line. It doesn't really matter. I'll just choose A. That feels like it makes sense. So that is 3, negative 1, 3. Plus K, and then the direction that the line is going in. All right, that's why they told us to do part A, because this is supposed to help us do this bit from point A to point B. This is the direction we're moving in. So that is a good direction vector for us to use. Okay, if the question was find the vector equation of the line, I would be finished and I would be celebrating, but it is not. So I've got to convert this to a Cartesian equation of a line. Now I'm going to do this the faster way, right? What you can do is write this out as I's, J's, and K's, and then group the I's and group the J's and group the K's, and let X equals this and Y equals this and Z equals this. So I'm going to do that all sort of at the same time. All right, so X, we're moving to a Cartesian form here. The X coordinate of this dot moving along the plane is equal to its starting X, 3, plus negative 2K. Negative 2K. Which is just 3 minus 2K. All right, what about the Y? Well, the Y is equal to negative 1 plus 2K. Negative 1 plus 2K. And the Z is equal to 3 plus 3K. Okay, and then I rearrange all of these to make K the subject. So this first one would be X minus 3 over negative 2 equals K, right? Minus 3 divided by negative 2. This next one here would be Y plus 1 over 2 equals K. And this last one here would be Z minus 3 over 3 equals K. Now that I've done that, I've got the Cartesian equation of the line. The Cartesian equation of the line is this equals this equals this. And you can see there is our formula for the Cartesian equation of a line. So it is X minus 3 over minus 2 equals Y plus 1 over 2 equals Z minus 3 over 3. All right, that feels good. And so now that we've done it the slow way, it should be very, very obvious how to do it the fast way by just looking at the bottom equation and understanding what you need to sub into it, right? A1, A2, A3. So minus A1, minus A2, minus A3. That's along our numerator, right? Minus 3 plus 1 minus 3. Where are those values coming from? It's coming from our A, right? Our starting point. Now we chose A as our starting point. Minus 3, not positive 3 because it's minus whatever that is. It's minus whatever that is. So not minus 1, positive 1. It's minus whatever that is. Okay, so that's where those are coming from. Where's the negative 2, the 2, and the 3 coming from? It's coming from the direction, AB, right? So rather than do this, it's just what I've done here, you can, if you want to, be able to jump straight to the Cartesian equation of the line. If you have a point on the line and the direction, you can substitute those values straight away. All right, so that's part B. Part C says determine the Cartesian equation of the plane if it's this. Point A lies on the plane and AB is perpendicular to this plane. Okay, equation of the plane. We know how to do that. Now, an equation of the plane, so let's just call this part C because it's not going to take very much work at all. R dot N equals A dot N. All right, so N is a vector that is normal to the plane or perpendicular to the plane. And it says here point A lies on the plane and AB is perpendicular to this plane. So we have AB here. So N is whatever that is, negative 2, 2, 3, and negative 2, 2, 3. All right, that's our N. Now, A is a point on the plane, and it tells us here that A is point A, and point A is 3, negative 1, 3. 3, negative 1, 3. Now, R, what's R? All and every vector that ever existed, just X, Y, and Z. Okay, so this here, we actually have to do that as a dot product. Now, if you want to, you can pull out your calculator and do it as a dot product on your calculator. Honestly, feels like it's maybe more effort than it's worth, but let's do it. We go option, and we're doing a calculation of a vector. We're doing a dot product, and now we need to enter two vectors, so we can exit out of that, go math, go here, and we're going to enter two 1 by 3s, right? So 3, negative 1, 3, and then followed by a comma, and then another one of those 1 by 3s, negative 2, 2, and 3. Close up the bracket. And there's our dot product 1. Now, could you have done that as negative 6 plus negative 2 plus 9 and also have come to the answer of 1? Yeah, I think probably. Now, if this question said determine the vector equation of the plane, I would be finished. But I am not finished because I need the Cartesian equation of the plane. Very, very straightforward. It's just negative 2x plus 2y plus 3z equals 1. I'm just doing the dot product with a vector here that's just x, y, and z. And when I do that, I'll get that. That's it. All right, that is the last question in that series. Let's give it a little celebration. And that's been our week 4 solutions. Now, go into the description, go and find the next set of questions. They're going to be week 5. I am going to try to step up the difficulty. The first 4 weeks have been a bit of a warm-up, so expect a difficult question towards the end there. I think I'm going to throw some vector calculus into this as well, and it's going to be a tech-free one. Throw our calculator aside for a little while and do it all in our noggin. All right, that's it. I will see you next week.